All right, welcome everyone. We're gonna kind of let it take a minute as everybody comes in. Super excited you could join us this evening for tonight's Workshop Wednesday session. If you haven't seen my name, seen stuff by now, I'm introducing myself as Dr. John Lohr with the National Office, and I'm super excited to be bringing you this presentation tonight because uh, I can't think of a better person in the Science Olympiad organization to talk to you about Circuit Lab than our presenter tonight, Russ Burleson. Um, Russ has been a huge part of Science Olympiad, going back to his days when he was coaching his son and daughters through the program in Ohio. He's led programs in Maryland. And now he's doing his darndest to support the program down in Texas as well. Um, by Before we get into Russ and turn it over to him, a couple of things I do want to point out real quickly. First and foremost, if you have any technical issues you would like to report, you're worried about, like, hey, I'm not sure my sound is working, right? Please put that kind of stuff in the chat. All right. I do not put questions in the chat, partly because the chat moves and it's real hard to kind of keep track of questions. If you have questions, I really want to encourage you to use the question and answer feature, which is that little box kind of middle right on your screen. It looks like a little box with a question mark in it. It says Q&A. If you type your questions in there, it's easier for Russ and I to see them and keep track of them, and we'll make sure that we get those questions answered that come in. All right. Last but not least, one of the most common questions we always get, right? You will get the recording for this. Okay. Not only will we send it to you, probably sometime tomorrow, you should get the raw recording, but we're also going to get it up and post it on our YouTube channel. I'll make sure I post the link to the YouTube channel in the chat at the end of the session, as well as the link to sign up for some other workshops, because we got some great ones coming up after we take a little bit of a break for Thanksgiving. All right. So without further ado, I'm turning over to Russ. Russ, thanks for being here.
Glad to be here. Nice to meet everybody virtually. My name is Russ Burleson. As John mentioned, I have been with Science Olympiad now for, well over a dozen years as a parent, as a coach, as an event supervisor, as a state director. I'm on the National Physics Committee, and I'm an electrical engineer by trade. So I spent over 30 years as a practicing electrical engineer, and now I am retired from that, and I am teaching now high school engineering at McNeil High School in Round Rock, Texas. And so that's what I'm doing now. Without further ado, I'm going to try to share my slides here. Feel free to throw stuff out as you see it, and let's go. And so here we go. Okay, here we go. And so again, you'll be getting copies of these slides, and so hopefully you can see all this. But new coaches, welcome. Returning coaches, thanks for your continued involvement. And the purpose of this session is really not how to teach you how to compete in this event, but just to answer any questions you might have and prepare you for the upcoming season. Feel free to ask questions and share suggestions. And so with that, let's see. Hold on one second. Wait a second. Here we go. Okay, now I've got, here we go. Okay, and so basically for Circuit Lab for this year, you're allowed to use notes and or calculators. They've expanded the types of notes. It's not just limited to binder anymore. And basically about 50 to 75% of it's going to be a written portion, and then the rest is going to be practical or lab portion. So I'm not going to just read off the rules, but basically make sure you read the rules because they have changed from the last time we had Circuit Lab. you'll notice that some of the things for Division C, like bipolar junction transistors and digital logic, have been removed. They may be brought back the second year that we do this. But what you'll also notice is that Division B and Division C are a lot different than they have been in the past. And the reason was is that we were getting a lot of feedback that some of the Division B, the math was getting a little bit too hard. Okay. So just real quick, I'm just going to go through these very quickly. You'll get all these slides later. But basically, when I do a practice, I try to do between an hour to an hour and a half. I try to do it about once a week. I like to spend about 15 minutes grading homework, getting them ready, and then about 15 to 30 minutes learning the lesson a day, about 15 minutes doing an in-practice quick test or on that lesson of the day. And that's why we created stuff like the homework generator, which is an Excel spreadsheet which automatically creates random new questions for you. And then I also like to do about 25 minutes of practical testing. And that way they get really used to using multimeters and the other things you want to do for practical. And then we send them out with homework. Remember, the most important commodity you have is a coach's time. A coach is their time is of premier importance. Do not waste your time trying to help the kids do the homework they were supposed to do last time. They need to be doing that outside. If they come with questions, that's fine. But remember, be very respectful of your own time. Basically, we have a ton of resources at the national website. There's a ton of different resources. I even created a series of videos that's available on the national website and a series of PowerPoint presentations to teach about 12 different practices to get them ready. Okay. Please note that that's just the way I taught. It's not necessarily the best way. Find a way that works well with your kids. Feel free to use anything you find on the internet, like Wikipedia pages are great places to start your investigation, as are some of the Chat GPT and some of the AI tools. But don't stop there. But you got Khan Academy, you got Hyperscience. Just find the resources that work best for your students, the ones that they really understand. Okay. Now, one thing I always try to delineate is soinc.org is the national website. Anything that's on there, whether it's a clarification or an FAQ, or anything that's posted there is legal. Okay, they carry the same weight as the rules. Okay, that's important. But there are other websites like scioli.org, which is an alumni run website. And it's a great resource, has a ton of information, but keep in mind, a lot of the stuff that's put out there are people's opinions and may be based on older rules. So my general rules is that, when I'm doing the online coaching, I always tell them, always go with what their coach says, because it's very important that whatever you're trying to teach them, the students know that is the way they need to learn, as well as that's the way they need to prepare. Okay. You know your state and your region better than anyone else. Okay. One of the bigger things to make sure they all should understand the safety rules. The reason why we try to stay with DC voltage as much as we do is because of safety issues. And we try to stay low voltages, 12 volts or less, okay, for all hands-on activities. And in fact, we even try to get even lower when we can. Have them work on their binder. Their binders are a lifeline. I had a team that I've been trying to help, and both times they've shown up to me, they forgot their binder. And so I said, well, when you got your binder, come on back, because they've got to learn that binder is their lifeline. Even if they've got other resources, that binder is the quarterback, if you will, that will help them. And so here is some of the just general rules that we found with the binder, but just keep it small enough to be useful, but big enough to be comprehensive. There are a lot of topics in there. Make sure it's well tabbed and well organized, and make sure they use it for practice as well as for competitions. In the presentations, we're going to go, that you find online. There's basics of electricity, talking about Ohm's law and how to solve for current and resistance, knowing the difference between voltage and amperage and DC current and AC current. What is resistance? What is an ohm and how is it measured? How to identify batteries. This is very common, especially in Division B, for a lot of the practical um, for the practical labs. How to create batteries themselves. So you might be making kitchen batteries using soda as your acid, or you might be using a lemon or a potato. Okay, learning how to combine resistances into equivalent resistance, whether it's a parallel or a parallel or a series set of circuits. Okay, so learning how to do a series circuit, which is usually pretty easy, you just add them up, and then a parallel circuit where it's the you add up the inverses and it's the inverse resistance. Okay, how magnets work, what are north and south poles, okay, how to draw the lines on magnets. That is another set of very, very popular um, hands-on activities. Learning about how a field of current can force a magnetic field. Now, you will notice that we are avoiding all calculus, and that is true. And so just remember, look at the mathematics restrictions, but generally speaking, we try to keep it at an algebra level. They should know how a motor works. And in fact, motors are quite often the hands-on activities that we have them work on. Okay. Resistor identification, especially using colors, are important. One thing to keep in mind, if you have students who are colorblind or have vision issues, make sure that they work with the event supervisor to get around those issues, because this, again, is another popular hands-on activity. Learning how to handle multiple sources, how to do Kirchhoff's voltage law. Now, keep in mind, actual Kirchhoff's voltage law and Kirchhoff's current laws problems are only going to be at state and nationals for Division B, but you can still use that type of analysis to solve a lot of your problems. And so, learning how to, how to, do loops and points is very important for circuit analysis. Learning how light emitting diodes work. A lot of times for hands-on activities, the only type of lamps that they have to like give you an indicator that a circuit is on is an LED. So sometimes it's just going to be used as an indicator, but they should also know how a diode works, why it works when it's powered in the on condition and it's biased on, and why it turns off when it's biased off. When we get to Division C and we start talking about operational amplifiers, keep in mind that we will, that some of the presentations that I've done have really gotten into that. This is a very, very popular thing that we've added. It's really opened up a lot of the hands-on activities that we can do, and they should know how to do analysis on them. They should know how to do everything from infinite loop gain, how to break down an op amp and use it as an amplifier, or how to use it as a multi-stage amplifier. One of the big things is, keep in mind, physics teachers and engineers teach this subject differently. I'm an engineer, and so I might be a little biased, but I've always wanted to be a physicist. Okay. So if you look at tests, make sure that when you're going through old tests, try to get tests that were written by both physicists and engineers, because you just never know who's going to write your test. They're going to look at things differently. They're going to talk about current differently. They're going to look at whether it's conventional flow or actual electron flow as being how you define current. And it's just really important to know that neither way is wrong, but both ways are used quite a bit in our tests. Always try to send the max number of competitors. If you have two people, please try to do that. And just remember, even if the person doesn't know anything about Circuit Lab, they can proofread, they can double check, They can do all the little logistics side. They can make sure the binder arrives. And then one of the other things is just remember, put a little extra effort in the logistical issues. And when protesting, remember, event supervisors make mistakes, but they're almost always volunteers. And so one of the things is teach them how to respectfully bring it up and then also how to respectfully move on. I've seen a team get stuck on protesting an illegal question and spend 30 minutes and they ended up not answering any of the other questions. Even if they win that arbitration, they might lose the competition if they're not paying attention. Okay. The biggest things I like to tell people is that winners prepare and winners work together. Okay. And so that's the most important thing. The more you work together, the better off you'll be. The other thing is that if you're going to argue in a legal question, I came up with some general guidelines. And one of the key things is just be respectful. Make sure that you go straight to the specific rule. But then the most important thing is do not spend a lot of time on it. Make your argument and then move on because you've got to answer all the other problems. And so come back to the national website often, but remember, the students, if they're doing their job, should be the absolute experts at this. Okay, and then sometimes you may have students like one year I had one student who's really, really good at math and one student who's really, really good at magnetism. And they just sort of split the test. And that worked out really well. Now they were able to back each other up in case somebody got sick, but more importantly, it reduced the study load. Okay. Moderation in all things. You'll notice here, this was a binder, and it's still the largest binder we've ever seen, and it was totally useless because it was too large. This binder was over a foot thick. I like about a 2-inch binder, maybe 2.5, and that's about the maximum. Okay. All right. So with that, I'll take questions.
All right,
Okay.
Russ. We got a couple floating out here. Seems to be a lot of stuff on the binder side of things
Okay.
to start us off. So by notes, does that mean we can attach notebooks without 3-ring holes into our binder? They'd still be loose.
That is the new rules. I have not even done this. I'm terrified of this new rule. And the reason why is that quite often they will be at 2 student desks. And so, yes, they are allowed to bring virtually unlimited resources. However, keep in mind, these 2 students will have just a few seconds or a couple of minutes per question. They also are going to have limited table space. Okay. So I still believe the binder is the best way to go to act as like a quarterback. Because if you're trying to read a textbook, you've already sort of lost. The other thing is if you do use textbooks or other things, I would recommend tabbing them. Okay, next question.
All right. Yeah, just a real, if I could piggyback. The other thing, keep in mind, guys, is your resources are no good if they're not organized. So having loose things in the binder may not be the best way to go. And also, this is a new rule. So again, how it gets interpreted across 450 tournaments regarding loose stuff, especially if you're doing stations and that kind of thing, it could cause problems. So include loose stuff at your own risk. Next one comes from Don asking about are multimeters all the same, or is there something specific we should look for?
No, they're not all the same, but I will tell you that with the advent of digital multimeters, they generally all will suffice for what we need to do. It's not a bad idea to have them use a couple of different ones because they never know what they're going to see in the competition. Um, but the number one rule I have with multimeters, I never ever let my students measure current. I let them talk about it. I let them draw the diagrams of how they would measure current. But when you measure current, the multimeter is basically a short circuit. And if you accidentally put that across a voltage, okay, what will happen is the current will spike and it will blow the fuse and your multimeter is dead in the water. It's always a better idea to always have them measure voltage and resistance. Okay. And you will notice in the when you get to the troubleshooting section of uh, of the slides that are available on the national website, I talk about how to measure resistance properly, how to measure voltage properly. So the biggest thing is make sure that it's got voltage, make sure it's got resistance, and it's probably not a bad idea for it to have continuity with the bing, such that when it's shorted out, it makes a noise.
So Katie asked the question, the difficulty their students are having is powering their circuits. The rules don't clarify what to expect. And I think you may have touched on this, but because she wants to know what's the typical power source for building circuits specifically for Division B.
For Division B, most of the time it's usually going to be either a 1.5 volt. In other words, it's going to be like a double A or a triple A battery, or it's going to be a 9 volt. And that's usually about the highest voltage I like to do in a competition. Okay. Um, uh, that's usually what they should expect. Now you can get the battery holders that put two 1.5 volts in series, and it gets up to 3 volts, or you can go up to 4.5 volts. But most people do try to keep it 9 volts or lower.
All right. All right. Here's one from an uh, Prashanath, and I apologize if I'm butchering that one. There are a lot of resources for the written portion, but the hands-on portion seems to be very broad. Do you have any recommendations on where they can get access to a good set of lab experiments, in quotes, so activities the kids can practice to get ready for the hands-on portion?
That is a great question. As an event supervisor, it's a question I ask myself all the time. Okay. What we did try to do is that you'll notice in that we did try to mention some of the things that we would use for hands-on activities. But I would say there's a ton of resources for hands-on activities for electrical and magnetism available for elementary and middle school. There aren't as many for high school. I'm just here to tell you. I will tell you that make sure that they know how to measure resistance, make sure they know how to measure voltage, make sure they know how to troubleshoot a circuit. One of the things that we would often do is we would get small DC like LED lights and have them troubleshoot what the issue is with the Christmas lights. Okay. Um, another really good one is having them wire up a three-way switch, okay, which uses two single pole double throw switches wired up a very special way, um, and attach it to a light bulb. Sometimes they'll use snap circuits. So just generally speaking, make sure that they're able to do that. The other thing that I would say is make sure they understand resistor identification and that they understand honestly how to design a circuit. Because one of the more common ones is let's say, I'll give you uh, five one kilo ohm uh, resistors and have you design, let's say, a 2.33 kilo ohm resistance, and you put two in series and three in parallel. Okay. Um, and so that's one of the things that's also very common. And sometimes if the event supervisor doesn't have access to stuff, they will just have it be a paper exercise. But that's why kitchen batteries you see are very popular. Battery identification is very popular. Motor identification, wiring. wiring a motor, creating a simple electromagnet, all of those things are usually very popular.
Yeah. And if I can piggyback, I'm going to drop a link to an online simulation. It's the FET simulations. They're a group out of the University of Colorado. I know they have a couple of good online circuit ones to consider. I'm sure if you look at IEEE, their website under teaching resources or educational resources will have some fantastic I think, activities around circuits. And then the last place, and I think this is specific for high schoolers, is there's two groups. One is the I just blanked here. Oh, one is Project Lead the Way. They're a kind of a national engineering curriculum that a lot of schools may have, or you can look at, and they have stuff around circuits and electronics. There's also, if your school happens to have a career and technical education department, there may be an electronics class where the teacher has some ideas or recommendations. And last but not least, if you go outside, your local International Brotherhood of Electrical Workers, IEBW, right? IBEW. Yep. I mean, that's the electricians union. And they may have some good activities for, some starter activities for high school students as well.
Those
All
are
right.
all great recommendations there. Actually, I teach Project Lead the Way
Yeah.
as one of our CTE teachers, and I found it to be very useful. I will tell you that see one of the questions is, hey, what are some easier to understand alternatives? One of the things I like to do, just go to Harbor Freight or someplace, get the alligator clip leads and use those to connect your resistors together. Okay. Sometimes you can do that and it's a little bit easier to do. Okay. And then okay. Oh, and I will definitely change the background color. I was trying to follow the standard format. I apologize.
All right. Here's a question asking if and I think we've really kind of covered it, but just to restate it, right? If you are more comfortable with a 1 inch binder, that's great. If you want to go bigger and you think you need more resources, a 2 inch binder is perfectly fine as well, right? There is no limit on the binder size for this event. It really comes down to your personal preference and what is going to be the most useful for you uh, as a student when you're doing the event. Um, all right, Don throws in a question here about the rules given LED based activity as an example for a lab activity.
Mhm.
Would this be allowed for an invitational and regional competition, or is that really a state and national only kind of activity?
So the general rule that we've tried to implement is that if their LEDs have two things. If I'm going to do diode questions, okay, that is limited, at the appropriate level, okay? But we had to notice that pretty much you can't get lights that aren't LEDs anymore. It's very hard to get those small incandescent bulbs like we used to, especially if they're going to be 1.5 volt, 3 volt, or 9 volt. Okay. So what we found was that a lot of people were just having to go with using resistors for their indicators. So sometimes the LED is used as an indicator. And in that particular case, they just have to understand, make sure the polarity is correct such that it's on when it should be on versus you reverse the polarity and all of a sudden you got negative voltage going through it and it won't turn on.
Mm.
So, but that's more from a practical standpoint. You have to remember most of these event supervisors, they're either grabbing whatever's in the back of their school storeroom or they're ordering off of Amazon. And some of the stuff just isn't available like it was in the 80s or 70s.
Yeah. All right, we had two here kind of in the similar theme. Marina through the a version of this in the webinar chat, and Claire asked this as a Q&A. It's about what's the so Raina's is like if you had only one evening to get your binder together, what are some key components you would include? And Claire's asking like if you had more time to build your binder, you got any recommendations on how to put that what's the best way to put a binder together?
Great question. Okay. If you have 30 seconds to put a binder together, you put the rules in. Bar none. You put the rules in. You go to the national website, you download the rules, you put the rules in. Period. If you got a little bit of extra time, I like to always have the second page just a list of all of the types of problems and the formulas you might need. The most critical of them being Ohm's law, V equals IR. Believe it or not, V equals IR and knowing how to combine series and parallel resistors will help you solve probably more than 50% of your circuit type of problems. Knowing generally how a magnet works. So what you will notice is that if you go to the national website, and I'm going here for Division B, we have 15 different levels, if you will. And what I tried to do was number one is the introduction. And then after that, we go to static electricity, understanding what conductors, inductors are, how to make measurements, because I wanted them to learn how to use a multimeter. Number three was series and parallel circuits one, along with kitchen batteries. And then we got more advanced series and parallel circuits. And then we went to magnets, electrical charge. Okay. And that's the general way we built our binders at MagSig Middle School. And the reason was, believe it or not, I looked at the test and I wanted to build their knowledge as we went, but I also wanted to make sure we covered the most types of questions that they asked. Okay. You will notice that some of the other topics are not always a part, like RC circuits is not usually allowed in most competitions. Okay. I forget if they're even in Division C now, and they're usually only in Division C along with PN junctions, which is a fancy name for diodes. Okay. So I would probably follow that national thing of 1 through 15, and that's how I would build my binder.
Yeah. The other thing, and this is from my experience, both for the short time and the things that um you might want to make sure you have in your binder. I'm a big fan on like include the things that you might forget or get confused on if you're working quickly. So like Russ talks about knowing which equations match to which kind of circumstances. Um, like knowing constants and remembering constants. Like don't waste your brain power on it, list them out. The other thing is if you like with magnets, is it, does clockwise or counterclockwise matter? Like if that there's a situation where like direction matters, make sure you have a diagram that lays out direction or a note in your that say, hey, pay attention to direction on these kind of problems. So those little things that you might forget or you might overlook because you're working quickly, I think are great things to have in the binder as well.
Right.
All right.
And by the way, in those presentations, also just building on that, there is an actual several slides on how to build a binder. And you notice I sort of zipped through it. I gave like my 10 rules for building a good binder. Find from other coaches. You got to remember, my team never won nationals. So we did get fifth in the nation, but we didn't quite win. So there's better people at coaching than me. So feel free to steal from everybody.
So Mike asked a question, can we give more lab examples for both B and C? And I think we showed some places where you can, like take a look at FET, take a look at IEEE. I mean, there's going to be a mix. Like if you find an online activity, either through FET or like Explore Learning will have stuff on circuits and Why there's another group out of Cincinnati that does a bunch of online science simulations. Like you could translate those and get the materials and make those hands-on. But for IEEE, I'm dropping that link in the chat so you guys can go to their educational resources page. But that's the place I would look. Also, go to the bookstore if you mean you still have one, or go on Amazon and look for kind of like DIY electronics crafts or circuit crafts. Um, any of those little projects like um, build a paper robot where the eyes light up. Essentially, you're making a circuit behind the scenes. Like there's a bunch of those kind of non-traditional places may give you some ideas for activities or things that you could turn into more complex activities.
Okay.
All right.
And so I'm just going to go through these real quickly. Is there are MBs allowed to put calculus on the test? No, calculus is not allowed at any level. Calculus is not allowed. Okay. Is there a recommended kit for the practical lab test? Honestly, one that you find that works for you, but I'll tell you, most of the time, they're not using a practical kit. They're just using loose resistors and stuff like that. Uh,
Well,
one
hey
of the
Russ.
questions that was asked about, will they be given a larger voltage and be required to reduce it using a voltage divider? Yes, that's a great hands-on activity. And it's also one that you can do as a paper exercise. And I think I accidentally cut off John. I'm so sorry.
Hey, I've no problem, man. I want to go back to Bill's question about a recommended kit for lab tasks.
Hmm.
Our partner, Ward Science, offers a circuit lab kit that is all about teaching the basics of circuit lab. And I give me a second and I will pull up the link and drop that in the chat. Okay. And
Okay.
Misha's coming back with in the past invitationals have put calculus on the or the past two invitations you've been at. But that's the invitationals doing. I mean, calculus is not part of the exam, the event this year. Um, so you may end up running into it, right? But you shouldn't. And that's something that obviously to keep in mind as your team picks invitationals for the future. If an invitational is going beyond the rules, you guys got to decide whether or not that invitational is worth your time and money to participate in. Because invitationals are supposed to be practice for you. And if they're not giving you the material you need to practice, it you may want to rethink whether or not that invitational makes sense.
Okay. So somebody was asking about the topics for Division B. We have a list. They're in the rules. So that is the list of all the topics that are legal, if you will. Generally speaking, if something is related to those topics and not prohibited, they're legal. One of the other questions is that can older dial type meters, including galvanometers, be used? Absolutely. You will occasionally see those. They're rare because they're tough to get your hands on those. Okay. The other thing is, you know, for the lab portion, um, is is it reasonable to have a full bridge rectifier in a lab? Yes, it would be full. It would be. We see a lot of Wheatstone bridge type problems as well, and so I would say that that is okay. Let's see. Can you expect breadboards? Yes, you can expect breadboards if for no other reason. The reason why you may expect breadboards is because it makes it easy to create multiple stations. Okay. And again, event supervisors are trying to figure out how to do this. Okay. Um, Snap circuit maze, they're useful. Everything's useful as long as they're learning about series, parallel, voltage, current, etc. Okay. Let's see. I'm just trying to go through. Is there a great textbook in physics? I'm going to leave that to the science teachers out there because I'm not sure what's the best one to teach sixth graders. I sort of developed my own method that was very focused on just circuit lab topics, but there are a lot of really good resources out there now. Um, let's see. I'm just trying to go through this. Is there a modern equivalent for Radio Shack? Yes, Amazon. Anything you used to get at Radio Shack, you can get on Amazon. That's why Radio Shack went out of business. So you can order your resistors there, you can order your breadboards there, you can order your voltage, your battery holders so that you can create a 3 volt voltage source. Okay. The and can we please post the link to the national website? Yes, we want to do that. Are they allowed to bring more than one binder? According to the way I read the rules now, they can. Okay. In the previous one, they were allowed one binder. My recommendation, have them work with one usually. And the reason why is, again, limited space and it helps them look through stuff easier. Okay. Let's see. What a student should expect the competition to be like. Do you sit and take a test and get called up and do a test that's 5 minutes long? Sometimes that's exactly it. Sometimes you do a station where they pick up their binder, and this is why you don't want to have too much stuff, and they move from one table to the next because and they'll make measurements over here, and then they'll have to do questions. Sometimes I'll have them in the back because I've got something that was very difficult to set up, and I've only got one or two of these stations in the back, and they get called up one at a time, and I give them, 3 minutes to interrogate the circuit. Okay. Let's see. I'm trying to go through all of these as quick as we were able to. We have to say the basic concepts in physics and engineering. So here's the thing. It is a physics-based event, okay? However, electrical engineers use physics to solve problems. And that's what these kids are going to be doing. They're going to be doing engineering, which is using physics to solve problems, okay? Let's see. I'm just trying to go through this. One of the questions that I see often, what type of hands-on activities, what type of questions? My recommendation is go to sciali.org. Go to that national. They've got an entire test. Uh, they've got hundreds of tests, circuit lab tests. Download those tests. Keep in mind, some of their answer keys may be incorrect. Again, it's not from the nationals, but it's a great opportunity to give a lot of questions. I would go and I would specifically hunt for tests that were written by a science teacher that focused on different things than I focus on so that my kids will be ready for anything. Okay. So find a lot of different tests. You can also find a lot of good hands-on activities. Okay. I'm just trying to go through all the questions.
Hey, the other place, if people are looking for exams and examples, there is a resource in the Science Olympiad store. It's the Circuit Lab starter pack. You get 6 tests worth of questions. Now it's very question focused. There isn't necessarily hands-on activities in there, but addition to the questions, you also get some notes about the event and details on the content. So again, back to someone who was looking, what do I need to do if I have a last minute thing for my binder and I want some help? Again, that resource is available and you could put that in your binder.
All right. I'm just trying to look at this. So the best advice I can give anybody, make sure you cover all the topics. Keep in mind that those 15 lessons that I gave were ones that I used. You can set it up differently for yourself. And the other thing is keep in mind that some of those topics are no longer included. Okay. So like RC circuits may not be included. Skip over that. Okay. There is nothing. And so one of the other things, and that's on the website that I think is very important. And so I'm about to share my screen here real quickly, is what I call the homework generator. Okay. Let me see if I can find it. Here we go. So the homework generator is this. And basically, it is an Excel spreadsheet that I created that has multiple tabs. It starts off with a material data sheet. And then I start at level one, Ohm's Law, VIR. And what you have is that you have a very simple series circuit where you have a voltage and you have three resistors. And it's, can you combine those three resistors? In this case, you have to add them. So this would be 290. What is the current through all three resistors? Can they solve for that? What's the voltage on all three resistors? What's the power on all three resistors? And what's the total power? And it does this for three different ones. And you'll notice on the back, it automatically calculates your answer key. So when I print this out, okay, I can just fold that over and I can give my kids three problems. And every time I tell it to print, every time I open it, or every time I hit F9, it randomizes and creates three new problems. So once they're able to do all three of these problems on the regularly and accurately, they can then go to the next thing, which would be level 2 parallel. So this is teaching them how to do very simple parallel circuits, the same type of thing. I get the voltage, it automatically creates it, and then every time I hit F9, it redoes it. Then we get up to level 3 combination circuits. Okay, so this is both a series and a parallel circuit. Level 4 combination circuits, okay, which is a more complex circuit. Level 5, which actually the kids after a while find out it's just as they're able to do this one so fast, they usually feel like it's more like level 2. Level 6 is as high as I really go with this homework generator, but it's a good way to have them practice. And you as a coach don't have to keep coming up with ones in your head, and it already calculates it out. We also have magnetism problems, so having them practice drawing the magnetic fields, okay? And again, it gives the answers on the back or on the bottom. The other thing that you'll notice here is that we will quite often, we've got multi-source problems. We've got combination circuit problems. So this one's an even more complex combination circuit. And a lot of people will say, wait a second, this looks a lot like a Wheatstone bridge. And I know that. Level 9, we get a lot of switch problems. Okay. Then we got a resistor. And what this one does is that it will create resistors for you to identify. Okay. It also puts letters down here so that in case your child is colorblind, they can see it. And then it has them do designs. If I have 5 7K resistors, configure such they make a 35 kilo ohm resistor. And of course, I put them in series. Okay. And so it has them practice doing these designs. We've got Wheatstone Bridge, which is a very common set of questions that we get. Okay. And so you'll notice we have a lot of Wheatstone Bridge. We have dependent sources, which is not as common unless you have an electrical engineer doing it. Electrical engineers, when they want to make it hard, they'll put in a dependent source. Then later on, we talk about the superposition principle, and this helps the kids learn how to solve things with superposition. And then when you get to the point where they're doing Norton and Thevenin equivalent circuits, here's level 14. This is where we go over the LED database and what the different makeups are for the different colored LEDs. And then we have the diode problems. And again, a lot of times you're not going to be quizzed on things about diodes, but this is also available on the national website.
Okay. Hey, Russ, real quick, I want to go back over this because we've gotten flooded with people asking about the homework generator. So where you can find it is at the national website, soinc.org, under the event pages for Circuit Lab. And there's a separate event page for Division B and Division C. Links to the national website, the Circuit Lab B page, and the Circuit Lab C page are in the chat. Okay, so that's where you can go and look at them. It is there for both middle school and high school. Okay. There is a question from Joanna about will the homework generator work in Sheets? I don't think so because it was created in Excel. So some of the macros and things may not transfer over to Sheets. If you want to try and download it and upload it into Sheets, give it a shot, but don't be surprised if something breaks. And Barbara asked a question, Russ, and since you created it, it's a better way. I'm going to give this one to you. Um, Part of her long set of questions is it practical to share the whole homework generator file directly with students? Or is it meant that you create something, print it out, give the students the printout, they complete it, and then the coach kind of checks it or you give them answers to check it?
Great question. I always printed it out. And the reason why I always printed it out was for exactly that reason, because if they got too far ahead, a lot of times they'd be busting, they weren't listening in class. And so honestly, the homework generator was created by me as a simple way. It had started out as an addition and subtraction generator, homework generator, because my kids were having problems learning their addition and subtraction tables. Okay. And so then when I started coaching, I found out I constantly was being asked, I need more help. They were having problems doing Ohm's law problems or resistance combination problems. And I was like, okay, let me just create it. And it is more complex. Um, it does use random number generators. And there are, you will notice that when you download it, you'll be able to change like the range that you'll be able to go through them. Um, by the way, but the other thing is that quite often it will print on the front it'll print on one page the random number thing, and then on the back page it'll print the answers. But a lot of times I would just print the front page, and I would be the only one with the answer key. And so you remember how I said we would do 15 minutes of just practicing? It almost always involved let's do a sheet of the homework generator. We also created a homework generator for machines. I have been meaning to add in to the homework generator some of the newer topics, in particular operational amplifiers for Division C. I've just gotten a little busy.
Hey Russ, real quick, I want to run through a couple of these. So Donnie asked a question about the size of the resistors. Donnie, there's over 450 tournaments. Neither Russ or I can predict how big the resistors are going to be and how readable they are. I mean, our event supervisors are going to work with the materials they have, and I'm sure they're going to take size and readability and color recognition into consideration as they build these, build the events, build the hands-on activities. Raina asks, are binders, or can you allowed to bring a binder? Yes, 100%. You can bring a binder and resources to this event. There's a question from Tasia Sweeney, and I hope I got that even close. Even if a student in 6th grade would like to participate in Science Olympiad, and there is a middle school team or a junior high team that is really made up of 7th and 8th graders, it's a conversation with the junior high team if they would be willing to take on the 6th grader. The reason we end up doing and saying Division B is 6th through 9th grade is because there are a variety of school formats across the United States. So some buildings are 6, 7, 8, and they're more of a middle school. Some buildings are 7, 8, and 9, early high school. Some are just 7 and 8. So we're trying to be open to everybody.
The other thing I would add on to that, John,
Yep.
look at the maturity and the aptitude of the kids because you don't want to crush their confidence. I've had 6th graders who were just not ready for the math or the science, or they weren't mature enough to put in the amount of work that was required. And the 9th graders would very much intimidate them. I've also had 6th graders who ended up making a varsity middle school team that went to nationals.
Yeah. Real quick. There's a question here. Barbara asked about a book, Make Electronics, by Charles Pratt. I'm not familiar with the book, but I would look. I think any resource you can have that offers you some hands-on activities and makes it more engaging or give you some ideas on what you can do, there's probably some value in it. Arzu asks a question, should the team do the writing part and then the hands-on part? That's really going to be up to how the event supervisor structures it at the tournament. And again, 450 more tournaments, we're not going to predict. So whatever instructions they're given in the based on their event supervisor is what they should follow, and be prepared for a couple of different formats. Don, we've talked about a couple of different activities and kits. There's a link in the chat to Ward Science, and they sell a Science Olympiad Circuit Lab kit that's really about resources and materials for the kids to learn circuits that I would recommend, but there are others out there. There's a question here, is there a time limit for the lab? Again, 450 tournaments. It's going to be up to the event supervisor on how they do it. Keep in mind, there's 50 minutes for the event. So you got to get the test done and you have to get the hands-on activities done. So there's a lot going on, and they're going to want to follow the instructions for this. All right, let me see real quick. Yeah, we've kind of talked about those. Amy asked a question about using your notes and binders for the hands-on. If you're using them for the hands-on section, that's going to be up to the event supervisor and how they've got their hands-on station set up, if there's a space to have your binder or to have all your notes. So you asked a question about putting in pictures and diagrams of circuits. Yeah, that's something you might want to consider having if that's something you struggle with or you think that will help you the best.
And by the way, guys, sometimes, and I say this as a guy who has been thrown in to be an event supervisor, sometimes with very little. There have been times I've literally stopped at the grocery store to pick up potatoes to do a potato battery on the way. There are times that I've stopped at Lowe's to get batteries or what have you, or wire. Or in some cases, switches. Like I was talking about those three-way switches. How do you wire up a three-way switch? I've had to do that before. I've had to do it where I swung by the auto parts store and picked up automotive fuses. Or also at Lowe's or Home Depot, I might have picked up circuit breakers and had them do the identification of those. There's anything that's electrical, it can be used, okay? Generally speaking, the more common things, having them understand, like, safety devices, things like that, those are all positive. And by the way, those are all in those presentations that are available on the national website.
All right. Yeah, and last but not least, while we still have it, there's a question here asking us to suggest books. Like literally, there's dozens of them. One of the things I would encourage you to do is, if you're looking to get started and you're looking for resources, before you invest a ton of money, do a Google search on open educational resources or Open SciEd. And both Open Educational Resources and Open SciEd are national programs to create free use textbooks. And they can be on physics, they can be on electronics, literally there's hundreds of titles out there for both middle school, high school, university, and community college. So I would encourage you to do that search first and find stuff you like. Also, find if you're really looking for and you're struggling with math and you just want something like bare bones basic, the one title I would recommend is there's a high school textbook out there called Physics First. And physics, the reason they call it Physics First is it's meant to be the first science class kids take in high school. but they've written the book in such a way and they've done all the calculations, all the problems, all the instruction in such a way that there is no calculus involved in the instruction. So that's a nice kind of entry level one if that's what you're looking for that you might want to consider.
One of the questions that came up is electromagnetics, like electromagnetic fields. Is that fair game? And yes. But generally speaking, because we don't do, divergence and curls and calculus, what they really want to know is how to figure out, if you know the direction of the E field and the direction of the B field, which way is that wave going to propagate? And understanding that they're orthogonal to each other. So it's more of a conceptual thing. Okay. The other question I saw was, what are some of the differences between physics and electrical engineer questions? Electrical engineers tend to focus on circuits. Okay. The physicists, they'll throw at you a lot more of the electron being impacted by a magnetic field, or they'll hit you with a lot more magnetic type problems. Okay, so it's that's why I said grab as many tests as you can from wherever you can, and that's really the best way to see what all the topics are out there.
Real quick, because we are at time, and I just dropped two links in the chat. One, the first link is the link to Science Olympiad TV. That's our YouTube channel. That we will be posting the cleaned up recording of this session there. It should be up late this week, early next week, for everybody. Also, everybody will be getting the raw feed of this video. So, you'll have that download probably tomorrow or Friday. But please understand, it's the raw feed. We haven't edited it. We haven't checked any of the transcript. We haven't checked the closed captions. So just understand that it's AI generated and raw feed. The second thing that I posted there is one last other thing about Science Olympiad TV. All of our workshops so far have gone up on Science Olympiad TV. So if you're doing Mission Possible, Engineering CAD, helicopters, Boom a Lever, if you're going to do Code Craze as a trial event, all of those events are up and posted, and we've hosted webinars on those guys. There are still like 4 more webinars to happen before the new year. So we have upcoming solar system, we have upcoming hovercraft, and I'm blanking on the third one, but the link is to the workshops page where you can sign up and register is there. And we've already started doing the webinars for next semester. And I'm starting to book those. So the ones that happen after January 1st will be up. We'll start populating that over the next couple of weeks. At the moment, there is an engineering CAD webinar up there, Heidi, for the students. And thank you. Engineering CAD is the one I was forgetting. That one's going to focus on the event supervisors and running the event. So that's more of a adult facing one. So if you're a state director, event supervisor, coach, that may be a good one for you to check out, especially. And I would encourage middle school coaches to check it out, because a lot of times middle school coaches can be asked to run events at high school events at tournaments. So that's a real easy one for you to do. We'll see. I'll have to see if I can get one on experimental design. Thank you for the suggestion. And I'll also see about the possibility of a machines one. At the moment, we do not have those scheduled. So let me see if I can find people in times to do it. But otherwise, guys, everybody, thank you for hanging out and doing this. Hopefully it was useful. If you would please help thank Russ in the chat. I thank you for taking your time and putting everything together and answering all these questions. And everybody, I wish you all the best for the upcoming Thanksgiving holiday. Students, teachers, parents, everybody, I hope you have great, relaxing holiday with and time with family and friends. And I wish you all the best on the rest of the academic semester, particularly for our high schoolers, and good luck on your final exams and everything. And everybody, good luck on your season. Have a great um, have a great season and hope to see you at a tournament.
Thank you, guys.
Bye, everybody.